Hello students, before starting the question, let's begin the concept. The concept is that suppose we have a radioactive element having the atomic mass that is A and the atomic number is Z. Okay, and this element undergoes a radioactive decay. And suppose that during this decay, a beta particles emits. So students, you have to consider that you have to remember one concept that during the emission of these beta particles, that is the atomic number is increases by 1 means what the product we got, suppose x1, in this process that is atomic number is increases by 1 and atomic number is going to increase by 1 and the mass number remains unchanged. Okay, now again we are going to say that this x1 undergoes again a radioactive decay, and during this process we have seen that is gamma particle emits. So remember students, during the emission of gamma particles, mass number and the atomic number remains unchanged. So we will got a new product, suppose x2, and during this process that is mass number remain unchanged. So we are going to write A only and the atomic number also remains unchanged. So we are going to write the same as it is. Now once again I am saying that this x2 undergoes again a radioactive decay, and during this process suppose alpha particle emits. So students, you have to remember that during the emission of this alpha particles, that is mass number, suppose we got a new product that is x3, and during this process mass number is decreases by 4, the xa minus 4. We earlier the what is the reactant in A, and during this process during the emission of alpha particles, mass number is decreases by 4 and the atomic number will be decreases by how much? 2. So we'll write as Z minus 1. Okay, Z minus 1. So this was the concept. Now come to the question. The question is saying that we have a uranium that is 235. What is the atomic mass of this? That is 235. And during the radioactive decay, we have seen that alpha particles is going to emit, beta particles is going to emit, and gamma particles we are going to emit. And it undergoes a series of radioactive reactions. And what the final product we got, that is lead. During this process, we have seen that what is the atomic mass we got, that is a 207. So students, we will discuss what are the different steps and how this uranium particles that is undergoes a series of radioactive decay, and the product at last we got at that is lead 207. Now in during the first step, suppose that is we have a uranium, that is you have a uranium, and what is the atomic number or atomic mass of this uranium, that is a 235, and this uranium undergoes a radioactive decay, and during this process we have seen that alpha particle emits. So students, you know that during the emission of alpha particles, that is mass number is decreases by how much? 4. So we'll see that the product we got as thorium, and during this process the mass number is decreases by how much? That is 4. And again with this thorium is again undergoes a radioactive decay, and during this process we have seen that beta particle emits. Okay, then and as students, we know that during the emission of beta particles, that is atomic number is increases by 1 and the mass number remains unchanged. So we'll see that we got a new product, and what is the name of this product? That is a proctinium. Okay, so what is the mass number will remain the same, but the atomic number is increases by 1. Now once again this proactinium is again undergoes a radioactive decay, and during this process alpha particle emits. During the emission of alpha particles, mass number decreases by how much? 4. So just subtract 231 with 4, we will get as that is 227. We will get as 227, and what the product we got, that is actinium. Actinium. Again this actinium product undergoes a series of radioactive decay, and during this process that is gamma particle emits. And students, we have known that during the emission of gamma particles, there is no change in atomic mass as well as in the atomic number. So we got a new product, that is a thorium. Having the same atomic number, having the same atomic mass as that of actinium. So that as 227. Again this thorium undergoes a radioactive decay, and during this project we seen that alpha particle emits. So since you know that during the emission of alpha particles, what is change in the atomic mass, that is it is decreases by how much? 4. So we will write as 223 because just subtract 4 with the 227, you will get as 223, and the new product we got as radium. Okay, this was the first step. Now come to the second step. The second step, it is saying that we have a radium, and it has atomic mass of how much? That is 223. Okay, now during decay of this radium, In this process, you have seen that alpha particle emits. So students, you know that during the emission of alpha particles, what is going to happen? That is, there is decrease in atomic mass. How much? 4. So just subtract this 4, that is 2 to 3. How much you will get? That is 219. Okay, and the new product we got as a radon. The new product we got as a radon. And again, this radon undergoes a radioactive decay, and during this process we will see that alpha particle also emits and gamma particle also emits. So students, you know that during the emission of alpha particles, there is decrease in atomic mass by 4 and there decrease in atomic number by 2. But during the emission of gamma particles, there is no change in atomic mass and also in the atomic number. So just subtract, that is 219 with a 4. So we'll write as that is 215, and we will get as a new product. That is, what is the name of this product? That is known as a polonium. That is known as polonium. That is PO. Now this polonium undergoes again a radioactive decay, and during this process alpha particle again emits. Okay students, and during the emission of alpha particle again the atomic mass it decreases by 4, so we'll write as 211. Okay, and we got a new substance. That is the, what is the name of this substance? That is lead. Okay, and this lead again undergoes a radioactive decay, and during this process a gamma particle emits. And students, you know that during the emission of gamma particles there is no change in the atomic number as well as in the mass number. So you write a new product you got as, and this mass number will be the same, and it is as that of a new product we got as a bismuth. Okay, and this bismuth again undergoes a radioactive decay, and we got a new product. That is, so during the emission of alpha particle decrease in the mass by how much? Decrease in the atomic mass by how much? 4. So we'll write as that is 2, that is 0.7. Okay, and we'll got a new substance, that is thorium. Again this thorium undergoes radioactive decay, and during this decay beta particles emits. So students, you know that during the emission of beta particles there is no change in the atomic mass. Okay, there is no change in the atomic mass, only there is change in the atomic number, and the atomic number is increases by how much? There is 1. So we will get a new product, and the name of the product we got as lead. Okay students, this was the reaction.